Alright, welcome to today's physics class, and we want to look at projectiles. So we want to look at three cases of projectiles. The first case, or the case one, is when the object is projected horizontally from a height. And the case two is when the object is projected upward from the ground at an angle theta to the horizontal. And the case three is when the object is projected upward from a height at an angle theta to the horizontal. So stay tuned as we go through the three cases. So for case one, we have the diagram for case one when the object is projected from a height. And here is our initial velocity u, and the distance from the cliff to where the object will land is called the range, and the distance from the ground to the top of the cliff is h. Now in this case, there are two things you are going to be asked to find. The first thing is the time of flight. What time will it take the object to move from the top of the cliff to the ground? So the time of flight here, t, is given as the square root of 2h over g. Here our g is equals to 10 meters per second square. That's acceleration due to gravity. And then for the distance from the cliff, foot of the cliff, to where the object is landing, the range r is going to be given as the initial velocity times the time, and this will give us initial velocity u times the square root of 2h over g. Remember that our t here is 2h, the square root of 2h over g. That's for case 1. Now let's look at case 2, which is the most common case in most cases. Case 2, when the object is projected from the ground at an angle with u at an angle theta. Here we have the maximum height h. From the point of projection to the point of landing, we have the range r. So in this case, we are going to derive three things from here. First is the time of flight, capital T. This other one, we are using the time of flight as capital T. Why? Because the time it takes for the object to move from the ground to the maximum height is the same as the time it will take it to get to the foot of the cliff. Now, here we are going to have T is equals to 2u sine theta over g. That's the time of flight for the object that is projected in this case. And the next thing is going to be the maximum height h. H here is going to be u square sine square theta over 2g. Now in this case, when you are asked to find the maximum height, you use u square sine square theta over 2g. Some students make the mistake of squaring the angle. Please, you don't square the angle, you find the sine of your angle. Let's say we are looking at sine 30, sine square 30. First we find sine 30 and then we square our solution. Now for the maximum height, when the angle theta is equals to 90 degrees, our h become maximum. Our h is maximum at 90 degrees. So our h max here becomes u square all over 2g. That's the only angle that we can get the height as maximum. Now for the range, the range r is equal to u square sine 2 theta all over g. Here you multiply your theta by 2. So if our angle of projection was 30 degrees, you multiply it by 2, it becomes 60 degrees before you find the sine. But here you find the sine before you square your solution. So when our angle here at theta equal to 45 degrees, we have our r max as equal to u square over g. So this is the only angle that people can use to get a long distance projection. That's for case 2. Now let's look at case 3, which is a bit rare, but it can come up in any examination. For case 3, when the object is projected from a height. Now let's say this is the cliff, and we are projecting something from this cliff, and it gets to the ground. So first of all, we are going to have two things here. We are going to have maximum height here again. We have another height here, h. We have our maximum height, h. We have the height of the cliff, h. We have our range for this other guy, and then we have the final range, r. See how a bit complicated this one is? So here, for this one, we can also find other things. So imagine you are asked to find the time of flight. The time of flight here, t, is equal to, first you can find the time of flight for the up part here, which is 2u sine theta, remember, over g. This one will stop here. That's your time. But the time it will take it to reach here, so our time of flight, let's use capital T. Our time of flight, this one is just to end here, and the time for this other guy is just like case 1. So we add plus the square root of 2h over g. This h is this other one. This h is for this other one, from here to here. Are we together? I hope you get that. Now, for our range, our maximum height, h, is this h is u square sine square theta all over 2g. Then, if we want to know the maximum height, since we know the height of the cliff, we just add the height of the cliff and we can get the total height of the projection. And then our range, this other r, is equal to the range here, our small letter r plus, now our small letter r here, that's for the upward one, is just u square sine 2 theta all over g plus the range of this other side, this side, let's call this r2 or so, plus our u square root of 2h over g. I know that this case 3 looks a bit new to you, but we can find our time of flight, our height, our range from this. So please like, share, and comment. You can drop your question on the comment section. Thank you.